So for our objective is, the first one is to investigate the relationship between the separation distance and the electrostatic force between 2-point charge using MATLAB simulation. The second one is to verify Coulomb's law by analyzing the relationship between the electrostatic force and the inverse square of the distance. And the last one is to compare the attraction and repulsion forces between unlike charge and like charge.
What is Coulomb's law? Coulomb's law states that fundamental law in physics that quantifies the amount of electrical force between two stationary, electrically charged particles. For example, when it has two charges, which is positive and positive, it will repel to each other. But if it has a different charge, which is negative and positive, it will attract to each other.
Now I will explain the code that we use throughout the MATLAB simulation. For line 5 until 6 are the constant that we set, which is 1 over 4 pi mu naught. The line 9 is the distance between two charges, starting from 0.05 meter to 0.5 meter with an increment of 0.01 meter. Line 10 is the Coulomb's formula. Line 12 until 13 is the code to sort the distance and the force which is obtained through line 9 and line 10. Line 15 until 20 is the code to plot the force versus distance graph, which x-axis is the force and y-axis is the electrostatic force. Next, line 24 until 29 is the graph for the force versus 1 over r squared, which are used to prove the Coulomb's law. Next is line 33 until 37, which is used to test and calculate the repulsion and attraction between the two charges. And finally, line 39 until 48 is the final graph to simulate the attraction and also the repulsion of the charges that we have obtained in the previous line.
Now, I'm going to present about the verification of Coulomb's law. This graph verifies Coulomb's law, which states the electrostatic force is inversely proportional to the square of the distance between two charges. As shown in the graph of force versus 1 over r squared, the data forms a straight line. This matches the linear equation, which is y equal to mx plus c, where the slope represents the constant KQ1Q2. The graph shows that when the distance between the charges decreases, the electrostatic force increases rapidly. Likewise, if the distance is double, the force becomes only 1/4 of its original value. Therefore, the experimental results closely agree with the theoretical prediction, confirming that F is proportional to 1 over r squared, which verifies Coulomb's law.
Next slide is attraction and repulsion between electric charge. Looking at the graph on the right is Flo's electrostatic force against distance for two charge configuration using Coulomb's law. Starting with attraction, when positive and negative charge interact, they produce a negative force value. The charge or curve sit below the zero line, meaning the charge are pulling toward each other. This attraction is strongest at close range and weakens at the distance between them grows. Now, for repulsion, when two positive charge, they produce a positive force value. The blue curve sits above the zero line, meaning the charge are pushing away from each other. Just like attraction, repulsion is also strongest at close range and decrease as the charge move apart. In conclusion, opposite charge attract while like charge repel, and in both cases, the force is strongest when the charges are nearest to each other.
Now, let's look at how distance radically changes how electric charges interact. This slide visualizes Coulomb's law, which maps electrostatic force against the distance separating two charged objects. If you look at the graph on the right, you'll notice a steep dramatic curve rather than a straight line. This immediately tells us that the relationship is nonlinear and it decays rapidly. So, let's look at the two extremes here. At short range, when the objects are incredibly close, at just 0.05 meters, the electrostatic force peaks massively at about 3.6 newtons, while at long range, the moment that distance pushes past 0.2 meters, the force plummets. It flattens out so aggressively that by half a meter, it's already reaching near zero. So the core takeaway here is that distance is the most consequential variable in electrostatic interactions because it follows an inverse square law. Simply doubling the distance doesn't cut the force in half. It drops it down to one quarter of its original strength.
As for conclusion, our MATLAB simulation perfectly backed up Coulomb's law. The graph showed the exact mathematical relationship we expected and the charge behaved exactly as physics dictated. Even though it was an ideal simulation without real-world factors like humidity, it proves MATLAB is a great tool for modeling these forces.